Hi everyone. In this video, I'm going to be talking to you about some of the latest changes that we've made to SecurityReview.ai to give you an enhanced set of capabilities that you can use to make your security design reviews and threat models a lot more powerful, a lot easier, and a lot more comprehensive. So let's start with the first one, which is our auto fix approach. We call it an auto fix, but it's really auto remediation or intelligent remediation capability. Now let me talk to you about what this is. Now, within any kind of project that you're threat modeling, there is likely to be controls that have already been applied, right? There's likely to be controls that have already been applied and already been, implemented within that particular project. Now, this is something that your documents might capture as part of it. Now, the previous issue or the issues with most threat modeling tools is that they give you threats and they give you countermeasures without any kind of context as to understanding whether that countermeasure has already been applied or not. Now, with SecurityReview.ai, what you have is that it intelligently recognizes when a countermeasure has either been partially implemented or completely implemented. And when it generates countermeasures, it generates the countermeasure, but it says, no, it's been implemented already. And it gives you a reasoning for why it believes it's been implemented. Of course, it's always based on human in the loop. Humans can interact and change it when they need to. But the idea here is that there is always something that is capturing the ability that it is implemented or not. So, for instance, in this case, we are doing a threat model for OpenClaw, which is a very well known AI project that I'm sure a lot of you have heard of. Now, OpenClaw has a whole, so we've basically the threat modeled OpenClaw's entire repository. You'll see that this is the code profile that Security Review generates for OpenClaw based on the repository. So again, we've not given it any documents. We just pointed it to open source repository, and it's generated a bunch of context for it to understand. Now, one of the things that this does is that it has some good security practices that OpenClaw is already maybe using, and it captures that as part of the profile, right? So you'll see that it captures high risk, high security issues, and so on and so forth, but it also captures some of the good practices that are happening within OpenClaw, right? So this is something that you have as part of this. Now, good security practices, it says, has some decent security mechanisms, and because of this, when we have done a review of OpenClaw, so we've done a review of OpenClaw, it's generated a whole bunch of threat scenarios and countermeasures. You will see that many of the countermeasures have been marked as either partial or implemented. In this case, I don't think there are any fully implemented countermeasures, but if you see partially implemented, you'll see that there are a bunch of countermeasures here that have been partially implemented. So if you see strong network binding policy as a countermeasure, it says partially implemented. And when you go into this, you'll actually see why it's partially implemented. It says that it's been, there is some kind of secure local host binding, which is good, but it lacks enforced policies for LAN deployments where administrators may use weak tokens. So it says that yes, there is something that's been done, but it's not good enough. So it recognizes intelligently the differences between very good implementation, which is solid implementation, but it also recognizes scenarios where the implementation is not so good, right? Or which is partially done. It has that distinction, and recognizes that and captures that as part of the countermeasure practice. This helps you because this helps you prioritize the nature of the countermeasures that you need to put in, right? That is really one of the most powerful things with our new intelligent auto remediation tracking capability that we've built into SecurityReview.ai. A lot of our customers now are building out AI projects, and threat modeling and security design reviews are essential for AI projects. One of the methodologies that has been making waves in the AI security space is Maestro, which is a purpose-built threat modeling approach for AI and AI related systems or AI adjacent systems or AI agents and so on. So one of the things that we have got automatically built in is that the platform automatically recognizes when we are threat modeling an AI or AI related application and starts adding Maestro mappings to that particular project. So when you look into threat scenarios, not only does it use the optimized own ISMS methodology that we use, But when you get into the actual finding, you will see that it also captures additional third-party methodology information like CAPEC or ATT&CK, as well as the Maestro mapping. So it says layer 3, Maestro, and it explains why this is mapped against Maestro, which is a purpose-built AI threat modeling system. That is what it captures here as well. One of the other things that Security Review really does well is continuous threat modeling, or what we also like to call internally design to development threat modeling, right? Now, this is where you can set up a continuously running workflow against a system that is like a system of record or a workflow tracking type of a system. So imagine that you are setting this up against a Confluence document where every single new document that is created is analyzed from a security perspective. That's where this sort of thing can come in. So Confluence becomes your design system, Jira becomes your workflow tracking system, and then you have code written in GitHub, which basically uses all of these design elements from Confluence. You have Jira tickets that map against that. So how do you monitor this entire flow, and how do you track security across this entire flow? That's really one of the things that we do with our continuous threat models. We have our workflow system that we've created, and you can set up different types of workflows. You can see, so you can set up different types of workflows for different data sources. You can see that you can do hub-based analysis, Confluence analysis, Jira. Again, you can set up a continuous stream of threat models that automatically are created when new items are added to this, right? So in this case, let me show you something for Confluence that we've done. So in this case, you'll see that this Confluence page refers to or is being referenced in multiple Jira tickets as well as in a GitHub commit that happened in a Git repository. So you'll see that this has been identified like so. It also identifies subtasks like Jira subtasks and captures that, and it goes into each of these things. And the cool thing is you have recommendations right from design to requirements that are tracked in Jira. So design probably going to be in Confluence, requirements tracked in Jira, and then development, which is in GitHub. So you actually get a full trace of security requirements right from design to development right within the system, and it automatically recognizes any references and makes updates based on these references. So even without having to for you to explicitly specify what to use, you can see that it creates this interactive map and starts referencing security risks based on this map. And you have information about concerns, recommendations, entities, what is the reasoning behind this, right? So it says which omit authentication architecture and so on. So it essentially gives you a very detailed rundown of what you would need to understand continuous threat modeling. One of the other things that we've introduced as part of Security Review is the ability to generate security requirements reports as well as secure by design reports as per CISA's secure by design parameters, right? So, in fact, you'll see here, this is a fictional asset management system that we've been threat modeling. So, you'll see that this is a secure by design report, and you can generate this on the fly, right? So, you can say, security requirements document, secure by, and of course, you can generate a whole number of other documents as well. So you'll see that this is mapped directly to CISA's principles, which is secure by design as a core business requirement, radical transparency, all of that stuff, right? So you'll see all of the specific items that have been captured as part of it, as well as the prioritization for those items, right? So you'll see each of those things related countermeasures, actions, and so on that map to something like this. So you will see that this is something that we have, as well as, of course, security requirements documentation that capture what kind of security requirements are necessary for this particular platform. So it says, okay, these are some things, and all of this can be either, uploaded to third-party systems, they can be exported to other system of record systems, and like Jira and Confluence and so on. And this is something that can be done quite extensively with our new reporting modules. One of the other things that we've implemented as part of Security Review is a self-learning system based on insights from what happens in that system. So the idea here is that the system continuously learns from changes that happen in the system. So let us say I change a particular security objective or a threat scenario from a particular priority to some a different priority, I get a insight, I get a recorded insight to say that, okay, this is how you should capture this particular type of threat scenario. So later on, when the AI generates new reviews or new threat scenarios, then it would probably be captured differently, right? So for instance, let's say I make a change to something like this, and I say, let's say, edit the severity or whatever it is, right? So I edit the severity to critical, and I save the threat scenario. Yeah, so let me just change this out. So now I'm saving this threat scenario because I'm manually editing it. So the AI has generated something, and I've saved this particular threat scenario because I've manually edited this. What happens now is all of this gets recorded as insights, which is like a self-learning system that tracks these changes. So you'll see that this starts getting recorded as updates to each field. Now, because of this, every single time a new TLS issue is created within SecurityReview.ai by the AI itself or by the agents, it automatically starts using the analysis from here and starts mapping it against that, mapping it based on the learnings from each insight. So the insights tend to create like this self-learning system, which allows the system to learn more, figure out more things, and then use it to make it more customized to your specific scenarios, your applications, your structures, rather than anything else. In fact, with our security knowledge base that you have, you can also upload your own knowledge bases, your best practices, and so on. And that also becomes part of the insight that says that, okay, I will only have to suggest this way that the company is using for authorization and authentication or something like that. You can use this for a whole bunch of things. Thank you so much for watching this video. We've been shipping a ton of stuff in SecurityReview.ai, and we're looking forward to new things and solving newer problems for all of you. I hope you found this video useful. Thanks so much for watching.